Are you going to do a countdown? All right. Hello, everyone, and welcome to our session today titled New Hybridities, Middle Eastern Minds, which is part of our Digital Futures series focusing on regional young leaders in computational design from around the globe. My name is Aya Riyad. Today, as Digital Futures Middle East Regional Manager, I am honored and excited to be introducing our talented panel of colleagues and friends. They are a group of young frontiers of digital design from the Middle East. And they are designers, architects, researchers, and creative technologists from a range of backgrounds who will be sharing with us their unique journeys in the field, their projects and research, what inspires them, and the influence of the region's culture on them. Through their presentations and discussions, we will be inquiring into the ways in which design meaning, intentions, and process can be constructed through computational thinking, representing, sensing, and making. These Middle Eastern minds will walk us through a plethora of research topics, including wearables, robotic fabrication, 3D printing, interactive design, digital and material explorations, and self-assembling design systems. The session today will include a 7 to 8 minutes visual presentation by each of our invited guests, followed by an open discussion and closing remarks. On that note, I would like to take this opportunity to now invite our very first presenter, Ava Aghakushak. She is a designer and creative technologist currently based in London. Ava's work focuses on the relationship between the human body, mind, and the spaces which it inhabits. Her work titled Sarotis was highlighted by Domus as one of the top design projects of 2016 and awarded the silver medal during the New York Design Awards 2018. Her work has appeared in Ars Electronica, Dutch Design Week, Resonate Media Arts Festival, Museum of Contemporary Art, among others. She is a member of the Interactive Architecture Lab and currently undertaking a PhD at the Bartlett School of Architecture at UCL. Ava, the floor is yours.
Okay, sorry, I forgot to unmute myself. Okay, so hi everyone. Thank you so much for having me here today. I'm very honored to be on this panel alongside such amazing speakers and thinkers, and even a couple of old friends. So I would like to focus this short presentation on my experience of being an Iranian woman and moving from Tehran to London, and how this change has shifted the way that I think about architecture and design. Sorry, wait, okay. Like any other individual who might have a shift in their system of belief, in the places that they inhabit, in their lifestyle, moving from one country to another can be extremely challenging and at some points very isolating. And that could be due to specific events such as lack of having proper communication skills, lack of having a system of support, or even just a weakened sense of belonging to your surrounding environment and the communities that you engage with. And that is totally fine because, again, any of us at some point in our lives feel alienated from ourselves, from our surrounding environments. But the thing that I realized after 6 years of living in the UK is that specific systems and structures are put into place to reinforce and maintain and even amplify this sense of isolation and, to an extent, alienation from the surrounding environment. And in no way I'm trying to suggest that I come from a country or a culture that there are no systems of oppression or structures for control. But I think what was new to me was how specific dichotomies such as outsider, insider, are tied into the Western system of thought, which again can also be traced back to the Cartesian dualism, which separates the body versus mind, the felt versus ideal, and so on. And this is why I knew, inspired by my background, I wanted to address this dualist way of thinking about ideas and concepts and even design. So I started to read more about post-dualist schools of thought, and I specifically got interested in posthumanism, because posthumanism talks about how the idea of humanness is not necessarily something which is tied to us coming from the same species and being the same species of Homo sapiens, but it's actually more of a status which can be granted to specific bodies and identities more compared to other generally known lesser quote unquote desirable bodies and identities, such as immigrants, such as people of color, queer bodies, trans bodies, and so on. Posthumanism also highlights the notion that human has been mostly defined in separation from the non-human realm. And therefore, posthumanism does not grant any onto-epistemological primacy to the human, and therefore addresses it in an interconnected and symbiotic relationship to the non-human realm. In this sense, posthumanism is a post-dualism stressing the hybrid and relational terms of existence. This is why I started exploring the territory of non-humans and testing to what extent a Homo sapiens body can be manipulated till it's not considered a human body anymore. I undertook this process by interfacing the body with technology. And as Manfred Klein suggests, the Homo sapiens, when they put on even a pair of glasses, have already started to change. So you can imagine how interfacing the body with technological active wearables can affect the body-mind. Donna Haraway also uses the idea and the concept of cyborg as a fluid identity, which makes thoroughly ambiguous the difference between natural and artificial, mind and body, self-developing and externally designed, and many other distinctions that are used to apply to organisms versus machines. And again, as I mentioned, are integral parts and components of the Western system of thought. In Sarate's project, we were specifically focusing on the materiality of these interfaces, and we were thinking about the notion of materiality as an idea which allows a focus on the actual matter of technology and how material bodies relate to one another, often intimately to the technical objects, and therefore can enhance the way the wearer expresses their identities or even explores the built environment and the surrounding environment. Okay, sorry, yeah. In Sarate's Wearable Futures short film, we had a stronger focus on the idea of materiality as something which can be used for designing the experience of the physical body, the social body, and the cultural body. And we were thinking how wearable technology should thus develop ways of integrating the body's tactility and sensitivity into the embodied design. This is why we were thinking about hydrogel interfaces and how they can blur the boundaries between human and machine, interior and exterior, artificial and natural, which also addresses Haraway's question of why human bodies should end at the skin. Although the way that we were thinking about designing these interfaces was an integral part of extending the human body mind and the concept of humanness, we were also thinking about how Clark and Chalmers suggest that the way the input of these devices are bound into the complex network of human cognition is also important in order to turn them as extended elements of human cognition. This is why in my latest project, in collaboration with choreographer and dancer Joe Korg and composer Bartosz Safransky, we are exploring and working with people with sensory impairments or neurodiversities, which affect sensory perception, to not only better understand the cross-sensory network of human perception and how new stimuli can be bound to it, but how we can actually recenter lesser known and lesser studied bodies in the center of our artistic and research explorations. That would be me. Thank you very much.
Thank you. Thank you so much, Ava, for sharing your intriguing work and research with us. This was truly fascinating to see. Right now, I would like to take the chance to invite our next guest, Basant Al-Shimi. She is an architect and researcher with a Bachelor of Architecture from the American University of Sharjah and Master of Architecture graduate from the AADRL. Her research focuses on robotically woven lightweight timber structures for infill sites in high-density cities that respond to the increase in demand for subscription services and raises the question of an architectural manifestation for a subscription living model. She is currently based in Dubai, UAE, working in different architectural practices and finding ways to intersect computation with art and design. Welcome, Basant.
Hi, everyone. Thank you, Aya, for the introduction. Sorry. Okay. Hello, everyone. It's a pleasure to be here today. My name is Basant. I'm Egyptian. I grew up in the UAE. I attended American University of Sharjah for my undergraduate studies and started becoming curious about digital fabrication and computational design towards my career there. A year after finishing my Bachelor of Architecture, I moved to London to study at the DRL. And this presentation is about my research there. So cloud living is about own nothing and access everything. That's the aim. It's about an increase in demand for subscription services, such as Netflix, that raise the question of an architectural manifestation for a subscription living model, where there are no tenants, but rather subscribers. Cloud living explores the benefits of subscription, including scalability and exchangeability of home functions, which are transformed by data collection and peer-to-peer space exchange. The proposal is subscription living as a model for collaborative consumption, where the cost of living is not borne by an individual, but rather negotiated within a larger group. The aim is to build a dynamic community in inner city London, which is fostered by technologies that enable data-driven design and combinatorial spatial customization. The research addresses two threads of investigation to give answers to a subscription living model: data-driven design and combinatorial customization. We investigate current models of subscription living, such as Airbnb and the Collective in London, as well as examples of combinatorial logic, such as transposed by Airbus. The proposal is comprised of robotically woven reinforced fiberglass components and a lightweight timber structure assembled from developable surfaces. This method of the digital fabrication is used to fulfill the goals of data-driven design and combinatorial customization within the functions of living. Cloud living challenges current concepts of home ownership by means of subscription living, where the subscriber owns nothing yet has access to everything. So the research is divided into a 6-step process. Firstly is primitive selection, which will provide a foundation for cataloging spatial requirements and developing a combinatorial organizational strategy. We considered several primitives, but I'll just focus on two over here: the cubic prism and the pentagonal prism. They're evaluated based on cell-to-cell connectivity. The pentagonal prism is the best suited for combinatorial subscription living, as it retains better cell connectivity even when cells are removed. Furthermore, the research focuses on combinatorial subscription model as a method for spatial organization. Cloud Living implements 7 subscription categories ranging on lifestyle requirements. Each category is inferred by measuring 3 types of capital: economic, social, and cultural. Each subscription is manifested architecturally by translating the original pentagonal prism into customized 3-dimensional weaving in the form of hyperbolic paraboloids. The woven doubly curved surfaces range in terms of size, portability, and complexity depending on the subscription category. These spatial conditions, coupled with the timber structure, provide an architectural language that serves the purpose of combinatorial customization. In this manner, Cloud Living proposes a range of residential units which vary in terms of size, privacy, and geometrical complexity. However, the spaces are not static. The combinatorial logic embedded in the primitive and the architectural manifestation of the subscription categories prompt spatial transformation in 2 ways: space transformation by data collection and peer-to-peer exchange, in which spaces can be traded between neighboring subscriptions. The 4th step in the research process is the method of constructing an envelope to host the combinatorial subscription spaces. The method will be explained on one of our prototypical sites. We had several prototypical sites, which were all infill sites between buildings. The first step is to define a boundary box. The initial primitive is placed at the center of the street-facing edge. The following primitives are added face-to-face within the site boundary. The ground floor is always used for public amenities that are served that serve the whole neighborhood. For vertical circulation, it's shown here in yellow. The social primitives are always attached to vertical circulation. It's shown here in magenta. Private primitives are shown in darker blue. And each social primitive is attached to the vertical circulation. This shows the iteration process, and eventually we come to a selection that's a moment of possible iteration. And then this method gets applied further on every floor. Next is creating a developable surface network. Each primitive serves as an input, and face-to-face polyhedra packing is created to encase the primitive. The normals of each polyhedra face create a line network, and this results in a low poly node. Out of the low poly profiles, developable strips are created that are extended and then trimmed by each other. For each polyhedron, the process is applied, resulting in a developable surface network, which also provides the connection points for the hypars. This is our outcome. The slabs are resting on the hypars, which transfer the load back to the structure. This shows the previous logic that I just explained applied to like 4 other sites, and it generates different outcomes using the same system. The 5th step in the research process is digital fabrication of the envelope. Cloud Living is comprised of robotically woven reinforced fiberglass components and lightweight timber structure assembled from developable surfaces. We have different individual components which together make our architectural language. This includes hollow timber nodes, tension cables, window weaving, and hyperbolic paraboloid weaving. All nodes are aggregations of developable surfaces. This shows the evolution of those surfaces. And all of them are cut out of planar sheets. Here we're using an adjustable loop knot to bend the wood after soaking it in water. The same knot is temporarily used to assemble all parts of the node together. The next step is timber weaving. The thread is soaked in resin and stiffens out in 24 hours. After that, the loop knots are removed. Also, for the hyperbolic paraboloid weaving, a robotic arm is used. This gives restriction of point-to-point linear weaving, which we take advantage of by weaving doubly ruled surfaces. With the same technique, we can also create planar surfaces like a floor slab. The window weaving is also connected to the fingers of the node, and added to this would be a second layer of glazing. So out of planar sheets, we are creating customized curved node parts with any given angle. And out of linear woven thread, we are generating complex doubly curved surfaces. The last step of the research process is occupying the envelope. For this particular site, we've located 35 households. It's an iteration, a moment in the combinatorial living model. Shown is a combinatorial arrangement here. This will change over time through user exchange and data analysis. Here we can see components with full occupancy. These are some details of the facade and social spaces, a private living space, some interior details. And this is a long section revealing the variety of spatial qualities within the subscription model. This wraps up my DRL research. I'm currently working in a boutique office called Inborn, architectural consultants based in Sharjah. We mainly work on residential projects, and I'm in the process of learning more about how I can possibly link my research to my practice and planning on pursuing my PhD to research the same topic further.
Wow, thank you. Thank you so much, Vasant, for this stunning presentation and for your exciting visuals. I think Gustavo and I would like to subscribe to your building. I would like to now move on to introduce our next guest, Sulaiman Al-Othman. He's a Doctor of Design student at Harvard University and a researcher at the Materials, System and Processes Group. His research focuses on using data-driven machine learning models to empower the design process in robotic fabrication and 3D printing. He has built several digitally driven projects and interactive installations in Kuwait and co-directed the Architectural Association Visiting School, which is a design and build workshop for constructing inhabitable pavilions that are digitally designed and manufactured. The floor is yours, Sulaiman.
Thank you. Thank you, Aya, again for this kind introduction. I am so honored to be here, this amazing group of people and researcher and practitioners. And I am so honored to present my project and share it with you. It's titled the Spatial Print Trajectories. It's actually one of my favorite projects because I actually was introduced to it in my first year in Harvard and during my master's degree. And now it is an essential component in my PhD studies. So just a little bit of a background about myself. I come from an architecture background, received my Bachelor of Architecture from the University of Arizona. Then I pursued a Master of Architecture at the AA. And then I decided I want to focus on technology and bridging the gap between material and design. And now I am pursuing this degree at Harvard University. Through my professional career, I worked as an architect in Kuwait, my home country, for a couple of years. And I co-directed the AA Visiting School, where we focus on design and build projects in shopping malls. And I also worked as a researcher at the Self-Assembly Lab, where I focused on self-actuating material. And now I am working at the MAPS group at Harvard University. So for this project that I'm sharing with you, it's called the Spatial Print Trajectories, and it addresses the current limitation of additive manufacturing techniques that are specific to viscous material. They are usually limited and restricted to layering the material in a 2D fashion, which usually result in material wastage, extended fabrication time, and most importantly, that they don't embed the material knowledge in their fabrication processes. However, this research develops this technique, which we call spatial print trajectories. It takes full advantage of the material behavior as it is being extruded by means of controlling certain fabrication parameter, like the machine, the speed of the machine, the extrusion rate of the material, to form these complex lattice structure and geometries. The story of this project begins by developing this spatial technique process of printing a clay lattice structure, and then taking it a step further by evaluating and addressing the issues of this process, mainly the issues of uncertainty of the material during the fabrication, and adding a responsive component to the whole workflow to introduce this real-time feedback loop to assist in the calibration of the material. And then proving finally that this workflow can actually be brought to the building scale and creating this inhabitable spaces. So the technique itself, just focusing on it, it's a very simple technique. It relies on 3 main actions, what we call anchor, dragging, and pulling. Anchoring is where we extrude the material at a higher extrusion rate with a very low speed, and then dragging the material along the surface, it's like vertically, and then pulling the material at a higher speed to create this coil-like geometry. The tool bath itself is very flexible and can be controlled because it is based on a voxel unit, which can be repeated in many different ways or stacked to accommodate certain curvature and the specific complex geometries. And with this technique, we have proven that we can actually save 80% of the material if we compare it to traditional 2D extrusion systems, which entail itself that we can actually reduce the fabrication time for the whole process. Also, with the tool bath voxel-based generation tool, it is flexible enough to accommodate certain geometries and certain typologies, and we proved that through prototyping. However, building up and going higher, we have faced with this inevitable uncertainty of the material. You can see the left image, the deflection of the global geometry built up, and this is a cause of the self-weight of the material, but also the force of extruding the material, right, on the already extruded layer. In this state of the clay, it is in a green state, meaning that it's not fully dry, and it's susceptible to being shifted and deflected. On the right image, you can see that the model is calibrated. And in this case, we have calibrated the model manually. After printing each level of the lattice geometry, we actually measure this level deflection manually with a ruler, and then apply those measurements to the tool bath generation tool and adjust it. As you can see, it's a very tedious process. So the next step, we introduced this responsive component to the whole workflow to ensure that we can print correctly on the already printed layer. And this diagram shows the whole integration of the sensor and the responsive component into the robotic workflow. And this diagram just illustrates how this tool bath generation voxel-based computational tool is easy to use to extract information for different kind of tool bath, like the printing tool bath, the heating tool bath, because we have to dry each layer after printing it, and then sensing each layer as well. The communication and the sending of information between the real-time physical printing and the tool bath generation tool for the calibration is facilitated through an application called the Machina Bridge, which was developed by one of our team members in the project. As you can see with this workflow, we can have highly calibrated prototypes, and then we can scale up the whole process to accommodate larger nozzle size, meaning that we can print larger in a bigger scale. And also with the tool bath generation tool, which is based on a voxel typology, we can introduce certain variation within the lattice structure. The final aim was to prove that this workflow could actually be implemented to construct large spatial designs, right? So we did come up with this sketch here based on the limitation of the room that we are printing in, because the robot is basically limited to the area and the space of the room itself. So we had to accommodate the design based on that. This has been done, I think, 3 days. The whole printing process took 3 days. This is just a timeline. And these are just final images to show the quality of the material. And if we go close up to some of the images, you can see the expression of the material, this unpredictable, uncertain material that want to be to express itself, but then there's this calibration system that makes sure that it is printed with high accuracy, right? These are some final shot, and I will conclude the presentation with this image. Thank you, Aya. Thank you, everyone, for listening. Yeah.
Thank you. Thank you so much, Sulaiman, for this really insightful presentation. It's really interesting to see how you follow different processes to basically come up with this kind of body of work. So thank you for sharing that. I would like to take the time now to invite our next presenter, Hebeis. Heba is an architect and computational designer focusing on data-driven and fabrication-driven design and artworks. She recently finished her master's degree in architectural computation at the Bartlett School of Architecture at UCL. Before that, she joined a consultancy office in Abu Dhabi, where she worked for 3 years on a number of architectural and urban projects in Abu Dhabi and Iraq. Next to her professional work, she also became an active member of UNAT organization, the United Network for Art, Architecture, and Technology, where she collaborated on developing a number of explorative computational design projects. Her work is a continuous research on the intersection of coding, art, and design. Welcome, Heba. The floor is yours.
Hello, can you hear me? I think you see the wrong screen.
Yes, we can hear you. If you don't mind just sharing your screen. Perfect.
Perfect. Thank you, Aya, for the introduction. Yes, so I have graduated from University of Sharjah in 2017. Back then, my background was not really, I didn't focus on computation or parametric design at all. I started to explore computational design in 2000 through workshops from UNAT and IAC Summer School. After that, I traveled to Madrid to have a 3-month course in Madrid to explore computational design and parametric design. After that, it was 2020, the pandemic happened and we were stuck at home, and I spent to further advance my skills in computational design and explore different projects. After in 2020, at the end of it, I joined Bartlett, the Architectural Computation Master at Bartlett, and I just finished a month ago. And following some of the work that I have developed before and after my joining. One of the aspects that I was particularly interested in the beginning is force fields. Playing around force fields and formation and manipulating the resulting curves by creating a parametric tool that can generate unlimited numbers of variations of artwork. So this project was, it's an abstract artistic project that I started with creating 2D and 3D. And here, moving from the 2D into the 3D force field curve, at the structure and the curve qualities like curvature. After that, I started exploring changing those curves into a mesh. This created more possibilities to have a physical form that can be fabricated later on. This is another example of force field mesh exploration. After that, I thought it might be interesting to see how we can apply it to an existing artifact. So creating by this rippled effect on these surfaces, which are also 3D printable. This project is one of the projects that I have made during my master. It explored morphological optimization of active bending structure through changing the connectivity and topology of the structure. This is the overall process. Well, I start with a generic topology, and through a number of steps and simulation, I apply the forces and I create the connectivity of the rods, and based on running the multiple optimization to see the best location of the best optimization, the best topology and the best connectivity. As you can see here, the goal was to minimize the stress of roads and maximize the height of the overall structure. Here are different exploration that came out of the process. Some of them are failing, some of them are more successful than the other. The next project towards printability is another project I did in my master. This project explored the potentials and restrictions associated with concrete 3D printing technologies. The main focus on this project was to explore the computational side and the design of 3D printing rather than the fabrication side. So the idea was to implement the fabrication constraints as part of creating a set of visual instant tools that help the architect through the design process. The tool set consists of a number of tools that can work independently or as a network, taking a normal sketch from the architects and provide instant feedback according to principle. The tool also indicate the numbers and location of rails. So because there are a number of printing technologies, concrete printing technologies, one of the concrete printing technologies I was focusing on is a robot on rail. And the project is exploring how can we place the rail given a sketch from the architect, what is the best location to locate the rails. And as part of the project, like it's clear that the simplicity of the plan that comes usually with traditional buildings and traditional design does not necessarily mean it is easily buildable by this technology. And a more free form can actually be easier and better to be built using these technologies. So that's all for my projects. Currently, now after I finish my master, I am focusing more on coding and developing more tools for developing more tools and plugins. And I recently accepted an offer to be an assistant researcher at the Hadid Code, and hopefully I will be starting by the end of this month. Thank you.
Wow, thank you. Thank you so much, Heba, for sharing your work with us. It's amazing to see the different kinds of experimentations you were involved in. So thank you so much for that. Next, I would like to introduce another talented architect and researcher with us today, Norhan Taru. She's a multidisciplinary designer with a diverse background. She studied architectural engineering at the American University in Cairo. Then she pursued a master's in adaptive architecture and computation at UCL, where she was introduced to coding and physical computing as tools for design. This made her interested in public art installations and using computational design tools to create interactive art, which led her to design and build installations in Egypt. She's currently doing her PhD in Virginia Tech, where she is focusing on the human-computer interaction in digitized urban spaces. Welcome, Norhan. The floor is yours.
Hi, everyone. Thank you, Aya, for the introduction. Basically, I want to give a brief introduction on myself. I studied architecture, like Aya said, I studied architectural engineering in AUC, an American University in Egypt. And it had no computational background. And I was interested in learning more about computational design. So I went to UCL at the Bartlett School of Architecture, and I studied adaptive architecture and computation. And then I went back to Egypt and worked at Dar al-Handasa, where I worked as a landscape and urban designer. And I also did some freelance installations with a couple of collaborations. And I went back during last year and taught at AUC Introduction to Processing. And now I'm in Virginia Tech learning, doing my PhD in planning, governance, and globalization. I'm basically focusing on behavioral studies. So to start, this was a project that focused on subtle technologies. And I wanted to, so it was a project at UCL. I wanted to create, it's an art piece, and I wanted to create a conversation between the brain and a painting, just having a very subtle piece. And it's using an EEG headset. This is one of my references. So basically the headset is, you wear it and it detects your brain activity, and according to your attention or meditation levels, it changes the art in front of it. So this was one of the TED Talks talking about using EEG headset to change classical art pieces. And then this one, it enabled people in wheelchairs to paint to paint using paintballs just by focusing on making it move. So this is basically how it works. So the technology is you just wear the headset. It detects your brain activity, and it sends signals to the computer using the Bluetooth, and then it activates the Arduino board. So the materials that I used thermochromic paint, which is a paint that works. It turns to colorless when it's heated, and it's black when it's not. There are other types, but this is the one that I used. And this was an experimentation. So basically, I added a smart alloy behind it. So the smart alloy can heat up fast and cool down fast as well. And this was an experimentation to see how long it takes to turn it from black to colorless, and then how long it takes to cool, just so I can know my medium. And then this was the time detected. This was an experimentation using different kinds of painting. I just added paint on top of an image to detect what kind of forms do I want, because I wanted it to look like a very simple painting. I didn't want any technology to show. This was just me trying to test how much attention and meditation it takes for someone to focus and maintain this level, because the data is very messy. So you need to detect it carefully. This is basically the process. So you just sit in front of the painting, and it changes in front of you. This is the muscle wire behind it. And I just selected the time at 50. So this is the painting itself. It's just a board, it's just a frame with eyes and face, eyes and lips. I wanted to go for something that looks familiar and more human. When you're relaxed, the painting opens her mouth, it turns into colorless, and it was just a very playful thing. And then when you're not, when you're focused, it opens its eyes. So it's kind of like you're looking at someone. And basically, this was the setting. So you just go in to a room. Just want to bring it back. So you go into a room and you just see this painting and nothing else, like the wires are hidden. And this was different kinds of interactions. So in this specific case, she is not very focused, and then the painting reacts in a way where her lips just change. And then in another experiment, so he's very intrigued and relaxed at the same time. So both are activated, and you get like different results. And it's just like you have the painting, but it's just a very personal painting to you. Those are different kinds of interaction. Okay. So the second project I chose was my dissertation. And basically I wanted to explore my process. That you see, I was very like, it was an exploration process. I was exploring all the different kinds of technology, and I wanted to explore materials and testing materials. And so basically I wanted to use the intrinsic behavior of a material to have one sheet that goes from rigid to flexible. It was based on Darcy Thompson's on growth and form, basically how you alter the coordinates and then it gives you different results. So this is basically what I was doing. I just had the unit with different coordinates and just creating different forms. This was the unit that I was using. It has a width and a height and an offset, and it generated different patterns based on a parametric model. In this case, I started by 3D printing different forms. So this pattern is something that already exists. I was just altering it and taking the basic unit of it. So in this case, I was exploring nylon and density, making it more dense and less dense. In this case, I was exploring nylon and thickness, and then I explored nylon versus PLA. And it was a very long process. So I had to reiterate my thesis and focus on something that has rapid evaluation for various prototypes. So I used COMSOL, which is a multi-physics simulator. Basically, I modeled this as a joint on Inventor, connected it to COMSOL, and then it generated all the different prototypes. And in this specific case, so here I'm just adding the boundaries, and then here I'm just selecting the edges, and then I'm adding the stresses, and I'm seeing at which point does the material fail and how can I use it in what sheet. And then when I moved back to Egypt and I worked as a landscape architect and an urban designer, I was very focused. I was very interested in applying those techniques, but I was always very intrigued by the art and how to make something inclusive as a public space. So I collaborated with Jumana Abdelkhele on several installations. This was one of them, one of my favorite projects. It was in a music festival, and how people used them, like those blocks were movable, and how people change them and interact with them. And it was something that I was interested in maybe applying the computational design that I learned, not just in the form, but also in the interaction, which made me interested in studying human behavior and how they interact. So now I actually moved to DC. I'm studying at Virginia Tech, working as a research assistant, and I'm focusing on studying behavior. My program is not very computational. It's actually more behavior. I'm just applying the technologies I know. And it has a lot to do with basically how people interact with the space. Right now, I'm working on a research assistant, as a research assistant on a project about hiking and how what do users need? How does technology affect them? How does it change their behavior? And this is what I'm just starting my PhD. And that's it. Thank you.
Thank you. Thank you so much, Norhan, for taking us along with you in your whole journey and sharing this kind of stimulating content with us. I would like to now invite our next presenter, Mohammed Al-Shawwad. Mohammed is a computational architect, visual artist, and researcher based in Dubai. He holds a master's degree in advanced architecture from IAC, focused on research in digital actuation of building materials, and another master's degree from the Bartlett School of Architecture, where he focused on machine learning principles, agency, and robotics. He is also an avid musician and cinematographer. Welcome, Mohammed. The floor is yours.
Thank you, Aya. Sorry, just give me one. Can you guys?
Yes, we can see your screen now.
All right. Hello, everyone. Good to be here, and it's truly a pleasure to be with so many different, just so many different journeys and so many different creative processes, modes of thinking. I just hope I can bring something of value to the table. So this image right here describes me really well. I like to fry drones, and I don't shave. But so I thought let me start on a lighter note, and let me start with a project that I'm working on right now, and I'll connect it back to how was my research experience and contributor in what I'm working on right now. So this is an NFT collection that I have recently been developing, and of course, when you create an NFT collection, these can be in the thousands in terms of numbers, and you don't want to create those each one at a time. You want to create a code, an environment in which they can procedurally generate, and you start to realize very quickly that it's that the knowledge you gain from the individual unit is a lot more prominent to the functioning of the overall system than the environment that you set out for it to begin with. And that realization came to me throughout that research process. And this is where, funny enough, my project from the Bartlett comes into play. So the project was called Tetrobots, and my team, we were in the self-assembly research direction. And so part of our exercise was to develop a robotic unit that self-assembles, that talks to other identical robotic units and creates different spatial conditions. We started the exercise by basically starting from an existing sort of research. We started from the game of life, and then we gave ourselves certain, let's say, certain boundaries. And this boundary was create a table, right? And what we started to do is we took the code of the game of life. We started basically modifying the relationships between the different voxels to be able to create something like a table, right? This is where we started to realize how important it is to look at the rules that govern each individual voxel. So we started to learn, after creating so many of those prototypes, that combining research that has to do with overall systems of self-assembly with intricacies that have to do with each and every individual unit was kind of an uncharted area, but at the same time, it was kind of a point of interest. One of the things we learned during the research, during researching the game of life, is that each one of these voxels is kind of like a lazy teenager in its movement. And this is something we started to kind of introduce to our tetrahedral unit. So we started from a tetrahedron. And we started to create maps of movement for each and every one of these. And then we started to look at the kind of relationships between them in terms of creating space. So what kind of sequences would create what sort of spaces, what sort of geometries. We've seen, of course, we've seen a lot of research looking at sort of swarm intelligence. And so we took that and we started looking at machine learning as sort of the formwork in which we start to train each of these units. And we had a research fellow actually who helped us through this process, and he introduced to us the idea of unsupervised reinforcement learning, which is basically when you give rules that govern each one of these units, and you basically run the machine learning code over time, and the unit will do multiple attempts until it starts learning about itself and its own limitations. What is it made of? What are the different parts that it can move and what can it not move? What is rigid and what is flexible? And from there, we give it different goals, and we start to sort of make it reach that goal at different time intervals. So we took that kind of 2D movement and we started translating it into 3D. And then once you translate that into 3D, that's when you start to see the different relationships between the units. So we're talking now different units, not the movement of only one. And we sort of lift off the restraints of physics at this point, or what's up and what's down, and we just sort of aggregate those units to see what they can do. And when they do those things, how can they do them again, right? So how is this result taking place? And how can we start to recreate different relationships? And these are different examples, basically, of different pseudocodes that generated these morphologies. That started to give us an idea of, okay, so how do we create space? What are the different relationships that we can combine to create things that kind of occupy a certain space and create certain enclosures? That resulted in us having to think about how do we start to airtight certain spaces, possibly. And so we sort of integrated this sort of inflatable system that would create a solid unit. And then we started doing through different actuation prototypes with motors. We started prototyping those and building them out. Different tests, lots of failures, and then we reached sort of a final prototype which has sort of a like a magnetic attachment point between it and each and every other unit. This is the built prototype, and this is the relationship between one unit and the other. So after that, we started looking at different ways to sort of not only work within rules that have rigid rules, but actually can we create like spatial fields, and can we kind of house those within different existing geometries or given geometries so that they can start to take shape around these geometry fields. And then we did a case study. There was a big fascination with Mars at that point at the Bartlett, and so we tried to kind of do a case study where we take a use case for it in terms of kind of a habitation of a place like Mars, and can we start to make airtight spaces? Can we take advantage of like storms on the planet, generate energy, store energy? We took one of the craters on the surface of the planet and created a spatial field where we started to aggregate those units. There's some images. This is a section example of how one of those habitational units would look like. And this is me. Thank you so much. I currently work at the Sharjah Urban Planning Council, where we're looking at kind of revitalizing the public realm of the city of Sharjah. And that's it.
Wow, thank you. Thank you so much, Mohammed, for this exciting research and your extremely visually appealing presentation. You're truly a creative of many talents. Right now, I'd like to move on to our next presenter and invite Sarah Mukhtar. Sarah is an architect with interests at the intersection of computation, performance simulation, and data science for design. She is currently pursuing a PhD in building technology at MIT, and she holds a Master's of Science in Adaptive Architecture and Computation from the Bartlett School of Architecture, and a Bachelor of Science in Architectural Engineering from the American University in Cairo. Prior to MIT, Sarah worked at Kohn Pedersen Fox Associates, KPF, where she led applied research projects in machine learning and simulation, as well as managed their environmental performance team in their London office. Welcome, Sarah. The floor is yours.
Thank you, Aya, for the introduction. So hi, I'm Sarah Mukhtar, and I am, as Aya just mentioned, I'm pursuing a PhD in building technology at MIT, and I'm very excited to be part of this panel and present to you some of the computational explorations I did in the past, but most importantly, really walk you through my journey and how this contributed to the work that I'm doing today. So. Sorry. So I was trained as and worked as an architect in its traditional sense. So over the years, however, this traditionally clear separation between design and making, physical and digital, thinker and builder has been fading. And my interests and explorations really have been at the intersection of design, computation, and performance simulation. And today, computation really has a great potential to enable data-enabled and performance-driven thinking and design. And that's really at the core of the motivation to my work. And I also believe that this is really a much needed approach to tackle some of the challenges that face the architecture profession, such as kind of the rapid urbanization and urgency of the climate change agenda. So exploring the integration between computational architecture and design domains started with my studies at the Bartlett. To bring the two domains closer, I initially focused on how computation methods and algorithms can be integrated in design platforms through developing a series of interactive digital environments to explore 3D interpretations of computational algorithms. So really looking at algorithms in isolation, but also applications relevant to the architecture domain, including like here, a surface optimizer using genetic algorithms for solar installation. And then to explore really the merged boundaries between digital and physical integration design, we built an interactive installation that used light sensor readings to inform a digital simulation and visualization of a particle system. The herd game is really how we called our game, which really engaged people to use physical attractors and repellers to control digital particles towards achieve a collective goal. I then decided to explore a domain where those boundaries are even more blurred, material computation, where physical behavior can be computed through an understanding of the underlying material system rules and input variability. And that was explored through experimentation of smart materials and dynamic facade component design. And then this was further investigated by designing computation in a shading system. So that computation that is embodied in the coordination between geometry relative to a sun path and the corresponding movements generated by a shape memory alloys response. The latter was designed given an objective-based performance function to produce a desired facade behavior, and the variety embodied through integrating geometry, material, and connection variation in the system promoted diversity and enabled an adaptability of output that really augmented a lot of the material computation constraints. So that was quite interesting. And then with the aim to bring computation performance and simulation insights into the architecture practice and build an understanding of the challenges that face the profession, I went back to the industry and worked at KPF on developing computational high-performance design tools and workflows for a wide range of projects across scales and diverse climates. And the approach of performance-driven exhaustive search landed itself quite valuable in defining design directions and making decisions, but it became quite challenging at scale, which really motivated some of the applied research projects at the office. So one of the interesting ones that was led by Cobus Bothma, the applied research director there, and which I contributed to, is this investigation of a performance-driven methodology spurred by the needs for developing housing unit typologies that are adaptable to the diverse mix of targeted users in a highly dense development. So using a set of generatively designed housing units, defined performance metrics, and a matrix weights distribution strategy. We trained a machine learning model to cluster image representations of zoning plans in the performative solution space. And that really in turn allowed us to make inference about performance of any similar housing unit that was not really part of the set. And the good solutions were then virtually visualized for designers' feedback with an aspiration to augment that with a reinforcement learning model that would take into account the less quantifiable metrics. So that was followed by work that I led that looked at exploring deep learning methodologies to reduce the processing time of pedestrian wind simulation, and using a conditional generative adversarial network, a height map representation of an urban context was used to predict wind speeds. And the integration of the machine learning model to the designer's typical CAD environments was really key to the process. And it allowed really designers to see the impact of design moves significantly faster than typically the typical simulations will give you. And then when I joined MIT, I wanted to revisit the work, but really question this idea of urban representation learning models. And typically most of the work really looks at simple extrusion models, and this is how they represent cities. But that does not really capture the complexity inherent in cities, such as the diversity in building morphologies, trees and vegetations, arcades, and so forth. So part of the work was to encode complex urban representations among other model upgrades and used for input channels representing both the global height maps, so the maximum height of a geometry, subtractive features such as tunnels, curved balconies, arcades, also integrating topography and local features such as trees, shading structures, and so forth. But really in the absence of data-rich digital models of cities, it becomes very hard to understand and quantify the urban microclimate. So the focus of another project was to propose an urban feature extraction workflow that uses the publicly available geotagged equirectangular outdoor view images and couple them with computer vision techniques and deep learning algorithms to extract some of those key urban features that are needed for microclimate assessments in general. And this is really about what those available data sets can tell us about our environment when data and resources for simulation are not readily available. So lastly, one component of my work is also in representing and disseminating knowledge about the challenges that we face as a profession. And this is a data narrative entitled Too Hot to Be Outside that explores outdoor thermal comfort conditions in a changing climate. And through a series of interactive visualization, you can understand more closely how you feel in cities around the world today, about how it is changing and how much design have the potential to influence it. And with that, I think this is really a quick overview of my interests and computation explorations working across scales. So from the material component scale to the building scale and to the urban scale to compute the environment. And through my current work, I work on developing metrics, frameworks, tools, and workflows that guide us to make informed decisions about our urban future, designing cities that are equitable, livable, resilient, but also really thinking about global knowledge accessibility and impact. Thank you.
Thank you so much, Sarah, for this. It's truly interesting to see the kind of research you've done in your studies and as well in your practice. So it's been fascinating to see. Thank you. I would like to now invite our final presenter, Sadie Al-Badri. Sadie is a design architect with several years of experience in architecture and digital design. She finished her master's degree in 2017 from the AA MTech program, where she intensively studied the Mesopotamian marshlands and the architectural model of living between the water and the land. Sadie has global and culturally diverse professional experiences as an architect in several countries in the world, including the Middle East, Germany, Japan, and the UK. Currently, she is working in the award-winning British architectural design and engineering firm, Foster & Partners. Welcome, Sadie.
Thank you very much, Aya. Can you hear me well?
Yes, it's perfect.
Perfect, okay. So thank you very much for the invite and giving me the opportunity to be along these incredible talents and amazing projects. I've worked in different countries on on projects across the globe. Basically, I've worked in Jordan, in Germany, in Japan, and in London. Currently, I'm working in Frost & Partners, and I've studied in the German Jordanian University, GJU, and I've done my master's in the Architectural Association, MTech. I've done MTech with Michael Weinstock. So basically, this is an overview of some of the projects I've worked on. These projects vary in scale, context, climate. We have different users, different clients, and they're all in different parts of the world. So I really think that I was very lucky to have worked in very interesting companies on a lot of projects across the globe. Unfortunately, due to the limited time we have in this presentation, I'll talk briefly about only 2 projects which I've worked on in the AA. We'll start with the Lobster. So the biological model of the lobster shell was investigated, and a design strategy inspired by the natural system was explored. And the lobster skeleton, different regions of the shell have different degrees of stiffness. The most striking observation is the fact that all the parts of the shell are made from the same material, a fiber polymer called chitin, which is organized across multiple scales to produce variation in form and differentiation and performance. So several material and design experiments were conducted in order to understand the relationship between material and geometry. The work was developed schematically at a small scale using rubber latex and polypropylene sheets, a series of 2D patterns which were sticked on a pre-stretched latex sheet and then released to form 3D forms responding to the elastic force. So as you can see here, we have designed the pattern, pre-stretched the latex sheet, and then released it, and we could predict the formations, at least the 3D shape will do based on the input we give to the fibers we're applying on the latex sheet. So one question was scalability of the system. So we decided to scale up the whole model and work on a bit bigger scale. So we took this whole material and we implemented the fiber system on a timber sheet. I'll just show you a small video of the process. So basically using jig, we could pre-stretch the latex and then CNC mill all the timber panels and then apply these panels on the sheet, on the pre-stretched latex. And that latex were then released. As you can see here, we're stretching it. And then we applied a contact glue material. Then the fiber patterns using timber sheets were applied on the pre-stretched latex. We've tested so many patterns to see how the material and how the panels would react. So as you can see here, once the latex is released, we have the 3 double curvature forms are generated across these panels. And we've done some robotic experiments where we used robots to actually apply the glue precisely, because we were having some issues when we apply it ourselves. So here are some, this is a result of one of the panels that was generated in this project. The other project I'm going to talk about very briefly as well is the marshland, the Mesopotamian marshland. It's my dissertation project at the AA. I worked with Cesar Cheng on this project. So the marshland is a very unique condition as they exist between water and land. They are in southern Iraq between River Tigris and Euphrates, and humans occupied it in forms of islands. These islands were constructed from a combination of reed and mud. So we've explored the marshland on different scales. In this presentation, I'll talk about the building scale which also tackles the material system. So our design driver are the locally resourced lightweight material, the self-built vernacular building technique, and the environment. Currently, the only available building type in the marshes is limited to the guest house, which is called madif, and is built entirely out of one material. The main structure of this madif is the arch. So we're aiming to propose a form-active system using grid bending, which integrates different functions and provide larger spans. Of course, we have done some physical experiments to understand the mechanical properties of the material by increasing the bundle size or the number of ties. We have used basically the first principle that already exists there, which is the arch. And that's bundled and arched to allow and creating the first element. The second principle is branching. Because the bundle are made out of multiple reed, we could branch them at some point and an arch can span and create a surface. The third principle is weaving. So by taking two arch elements and connect them, we can go from an arch system to a surface active system, forming a type of a grid shell. Some other elements that are non-structural can be introduced to the system. The spandrel area between the arches can also be covered using the same material. The whole system is created by one material, that's reed, which is local resource and highly available. The shading system can be developed to cover the interiors during hot summers and allow some light and air and solar heat gaining during winter. So you can see here the spandrel area can be covered and used as a ventilation device. Different degrees of porosity can be designed, of course, to allow wind and provide cross ventilation. So each unit provides a side and front exposure, which can be blocked and opened to allow for light and wind to come in. The system can grow in an axial direction. However, as the system grows, the height of the arch can be changed at the connection point to generate a skylight. So what was interesting is that we've developed all of these architectural strategies for people that can actually implement them and enhance the current building model they have. We could write an algorithm that basically by giving it only the outside two arches, it generates and embeds all the structure, all the architectural strategies I've just mentioned. As you can see here, by changing and varying the curves, we can achieve more complex geometries. And then these geometries were tested using also digital tools, were tested structurally. As you can see here in the diagram, the digital tool helped us to actually determine what's the diameter of the bundle needed to achieve that height of the arch. You can see here that the digital tool also helped us to create a lot of variations and different densities of weavings and create all the structural, all the architectural strategies we've just talked about by embedding, for example, the skylight, the side windows, and the spandrels for ventilation. Also, by exploring further, we could achieve even more complex geometries. These geometries can also introduce some local architectural languages, including courtyards, and some open structures wherever you want to allow some more light. Here are the sections, and the sections show the transitions, the transition between spaces and the differentiations between the spaces we could generate within this shell. I think it's a very interesting ecological model that's at the moment between Tigris and Euphrates, and it's definitely worth looking at and further explore. Thank you very much.
Thank you. Thank you so much, Sally, for this inspiring and wonderful presentation. Definitely beautiful work, and it's nice to see that you try to apply some of your research to the region as well. So that's truly fascinating. Thank you all for these eye-opening presentations and for sharing your stimulating work with us. This basically wraps up our presentations segment and brings us to the next part of our session, which is the open discussion. I myself have some questions I would like to ask, and I'm sure our guests and our audience also have a lot of questions for you. Before I start, I would like to invite Neil if he has any kind of comment that he would like to add to commence our discussion.
Thanks, Aya. So I just wanted to say how stunned I was by those presentations. It really brought home to you how much the West depends on talent coming from outside the world. If you shift your perspective, all of a sudden you realize how much a place like London is indebted to cultures outside. I mean, I always have a joke with Ahmed about Mohamed Salah being the star who keeps the Liverpool football team, soccer team together. But I mean, when you think about it, when I was teaching at the AA, I didn't have a single British student, and a place like London, which has hosted obviously the AA and the Bartlett especially, has hosted all this talent from outside, and it is totally dependent on that. I mean, someone like Zaha, one of the most prominent architects in London, was of course from Iraq, from a Muslim-speaking country, so from an Arabic-speaking country. It just you shift your perspective, and suddenly you realize how these other cultures are dependent on that, and practices like Foster's and universities like MIT and so on. I'm almost left speechless, but I think it was great to put this together to really remind us or to see the kind of emerging talent. Well, one thing that came across more than anything else to my mind was the notion of the journey, because everybody presented themselves in terms of having been studied here and so on, and which I thought was fascinating in itself. And in a sense, I think we're on a journey, just a journey in terms of I don't like to use the term Middle East because it sounds like Middle East of what, But anyway, we're on a journey, and certain parts of the world are really picking up on these things. I noticed, for example, that the American University of Cairo was not teaching computation back in, I think it was 2014 or something, but now it is, and it's one of the leaders in many ways. And it's just, I'm just digesting all of this because it was really a fascinating session to go and see such talent available and such interesting personal stories. And let me just put it in perspective. I came to the States to work with a pioneer in 3D printed concrete, 3D concrete printing, Berok Khoshneves, who himself is from a Muslim country, from Iran. And when you put this all together, you can sort of see how much we are kind of woven together. So I'm not quite sure what to say because was simply taken aback by the extraordinary array of talent. But I thought it was beautiful to see, and beautiful to see something emerging out of these particular places. I mean, that's more than anything else. I always go back to this comment that Brett Steele made at the 10th anniversary of the AADRL, and he was saying it's not often when you're so forward-looking that you look back and see things. And of course we don't, but nonetheless we did kind of, in a sense, those journeys today were really, really powerful, and we looked back and saw this emerging tradition, which is, very soon I think this is going to be one of the really centers of pushing forward these ideas. But I thought the last project was particularly beautiful, seeing between the Tigris and the Euphrates, this thing, and of course this is where we all come from. This is the cradle of civilization. So I'm delighted to see this. I'm delighted to see many actually going back and working and pushing forward these boundaries in their universities. I don't have a question as such, but let me formulate these things. I was so taken by this astonishing lineup today. It was really an amazing thing to see. So thank you, Aya. Amazing confidence to put these all together. Thank you, and thank you for the presentations.
Thank you so much, Neil. I would like to also invite Gustavo and Bevlin, who are with us today on the call, if they would like to also comment or basically mention any questions they have.
Sure. Sorry about that. Caught me by surprise. Hello, everyone. Great presentations. I actually wanted to ask a question for Ava, because I think her presentation provoked something in me. So can you please talk about the idea of the post-human in the age of the anthropocentric? Because they're different views. And Neil has this great doctoral consortium event, I would say, every Sunday. And every thinker, you change your frame of mind on how the world works. So how do you see that post-human? And then how do you see in the age of AI and coming into the quantum? Because at some point, you can be extremely intelligent and driven, but if you have these tools, you can make a new, let's say, currency, an understanding of property, and an understanding of the self or the avatar. So maybe if you guys can address this future that you're seeing as young architects and scholars and researchers.
Yeah, absolutely. Amazing question. Thank you. I think just going back to my presentation, I think my experience when I moved to the UK and how, again, I was actually going through this experience of having an identity crisis, not in the sense of, oh, I'm Middle Eastern or I'm woman and so on, but it was more than that. It was like, I was thinking about like, what are my rights here? And the way that I'm granted actually rights to move around the world, because as a Muslim, like there was Muslim ban happening around that time or a couple of years later. So there were many things that were actually implying that I am not as human as I think, or in comparison to many other bodies and identities. And I think that made me, in a way, identify with non-humans more, because again, like my body was being politicized in my own country. Again, like the way that I was granted freedom to move around, the way that I was treated and so on. Again, all of them implied that I was something not human. And that was absolutely empowering for me, because I think there is something super empowering in the unknown territory. And again, as you were saying, like a lot of the things that a lot of the identities that we identify as, or a lot of the creations that we are creating, they're just other modes of being. AI being an extension of human intelligence and human cognition, and many other identities just being another type of being and another type of extension to the concepts of human. And I think that is absolutely amazing, because that shifts the idea of how we think about the world, that in a way re-centers every and any being as much valid as a human agent. And I think, again, that is super empowering. And that, again, shifts the dynamics from a hierarchical system of humans being at the top into something which I don't want to refer to as something which is flat, as new materialism suggests, but something which is granting rights according to every and any individual conscious being according to their needs. I hope that kind of answered your question.
Yes, Eva, thank you. And I think just to follow up, it seems as though different projects were addressing designs of people here, fictional clients, you as the architect slash client slash dreamer. Mm-hmm. But it's fascinating, some of the controls and analysis of people and how the machine works. I think that to me was revealing about this week. Mm-hmm. And it seems like that's the currency that we should think about. Does anyone else have any thoughts about where we are in the world, what we can change? And since you guys are future leaders of the field, you know, what do you want to tell the people that are not serving us as creators? What do you want to tell them or say?
Can I just say, Eva, that was a beautiful response. But to my mind, I would take the opposite approach. I would say that just shows how human we all are, right? I mean, I think that's really important to say. The other thing is, I mean, just from a theoretical perspective, in one of the comments that Andy Clark made, because he has a debate about whether we're post-human or not, and he takes the view that actually we are, what shows we are kind of human is the capacity, the plasticity of the brain to absorb these new tools as a kind of prosthesis to the way we're operating. And I think that that itself kind of like, you know, I think it's that process of adaptation that I'm witnessing today. And I think this is the astonishing thing, how you guys are absorbing these tools and articulating yourself as human beings, not as post-human, but as human beings. And I think that was the amazing thing, especially as a female from a Muslim country. That is really empowering to see. So thank you very much. Thank you.
Guys, I also just want to make a point here. Thank you very much for all of your presentations and incredible questions, and Ava for the nice answer. I think if we really want to start thinking about the future, we need to start acting now. Our planet, as we all know, is now endangered, and we need to take an immediate action. It's our responsibility as well as architects to increase the awareness with people, to actually make people realize the massive problem and issue we're in right now, and how can we as architects change the way we're building, we're planning to make it more sustainable, to actually help saving the planet. So if we're planning to talk about the future, let's start acting from now, because we're at a very, very serious moment now. Thank you very much.
Thank you, everyone. These are really, really interesting points. I wanted to bring up something because I'm curious to hear your thoughts about it. It actually happened to me a couple of days ago. I was a part of a panel, and they were like, we don't really think you should be titled as like an architect because your work is like completely different from the rest of the panel who are architects. What kind of like title should we call you as? I started thinking about it. I was like, okay, maybe like just call me as a like creative technologist. And they really loved that term, and they thought it was more fitting to my kind of work and the kind of research that I was going to show. So I'm curious now to hear your thoughts about, do you think the term architect, does it encompass all of these experimentations that we are trying to do, or have we in some ways, because of us like exploring these different emergent technologies, have we stepped outside of the role of an architect? So I wanted to know, what do you see yourself as, and do you think the term architect basically encompasses all of these ideas that we talked about today, or is it beyond architecture?
Well, if I may, I mean, I'll jump in and give my few thoughts. So I think the terms kind of changed. So our understanding of what architects do has changed over time and will change. And as we become more technologically aware, and as kind of issues like climate change and things that impact everyone everywhere become part of our vocabulary and part of what we do every day, I think those are going to become part, or are already becoming part of what the architect does. I think different people would probably disagree and would probably label architects in terms of doing different things different in a specific way, but I think that this understanding of architects has to evolve. What architects have always done was build building cities or spaces or environments that engage with people and that make their lives better. And I think that more holistically describes what an architect does, or at least what I refer to when I say an architect. So I think the new architect, the architect of the future, is going to be one that understands the tool, understands how we can make use of the data and what people do, and an understanding of kind of all of those different disciplines that come together to build this environment for people. I think that's going to become part of what in the coming years going to be what we think the traditional architect is. And then this is going to keep on evolving as we as things change, as our needs change, as our tools evolve. It's always going to change.
Oh, thank you. Thank you for sharing that. Does anyone else have a view about this?
I mean, I do, but I want to hear from the panel because we've had some great comments so far. Let me step back and let's hear some more comments. This is a great discussion.
I think I just want to briefly say that I think for me, there is a difference between an architect and an architectural designer. And I think I identify myself more as an architectural designer because I am thinking about space. I'm thinking about like the spatial relation between user, built environment, and again, the extension of human cognition and how our experience of living in the world, one aspect of it is its embedded nature, but there are also embodied, extended network angles to human cognition. And I think architectural designer might be a better fit for what I do. But yeah, I totally agree with Sarah's comment. Yeah.
But maybe let me just say that, I mean, I think this is, in a way, a really actually very crucial question. I think we've been great discussions today. It's interesting that the RIBA did a study on this, which they discovered actually that people were saying maybe in a few years' time, I'm not going to call myself an architect because what I do doesn't fit in that particular kind of mold, shall we say. I take a different view. I think we have to adapt and change and renegotiate and redefine what it is to be an architect. And I think, you know, I think to my mind, there are some very special things about having this kind of background training, which I think can allow you to operate in different fields as well. And we take that for granted. We don't realize. We know we're trained to design, we're trained to think three-dimensionally, and we're trained to have an understanding of material behavior. But you can deploy those skills in many different arenas. And I think that is in some ways what it is to be an architect. But I also want to extend that to a different sort of way. I think it's like you have the capacity to visualize possibilities and to see things. And to my mind, you know, what we did at Digital Futures in setting up this thing, that was an architectural enterprise. It was really thinking through how you could operate through systems. So I think the term itself needs to evolve. You know, it needs to change. Rather than leaving it behind, we have to renegotiate and take it forward and redefine the future because it is emerging and changing. And you know, I think there are many ways, especially with computation. What is interesting is the term architect also comes to that in the world of computation, to what extent those come together in some ways. And I want to cling on to that term architect as a sensibility, not necessarily about putting bricks on bricks, but about imagining a better future world. And I think that we have this astonishing visual imagination that allows us to do that. I think it's also a limitation in some ways, but I think we have to exploit that and see where we can take it. So I think we need to keep hold of that term.
I would just like to jump in. I think we as architects, I mean, you cannot make sense of who you are, who the people are around you, where do you live, what do you do on a daily basis without a basic understanding of your surrounding environment and where you live, the boundaries of where you exist. And sometimes you have the ability to set those boundaries, and those boundaries really start to dictate how you live your life. This is what we do as architects. And back in the day, we did it with the biggest and really only way people made things. So we were makers and we had materials. But then we had to jump on the next big thing, the next big way in which people make things, which is computation, right? Industries are shifting to completely digitizing, like complete digitization of their existence. And so this is how you make things now. And this is how you make sense of your environment now. And this is why this is where we jump in. We are, I think at this point in time, we have an obligation to be kind of a higher order of thinking of these new spaces that we exist in, both physically and digitally, computationally speaking.
Thank you, Muhammad. I definitely agree with a lot of the things you all said, and I definitely think the term itself can be needs to evolve in many ways, and I think especially in the region here, it's still being used in a very kind of conservative, traditional way. That kind of describes the more conventional role of an architect that I think we have, especially as a group of computational designers, we have definitely kind of moved forward with the term. So I think there's definitely a lot of catching up to do in terms of that. I would like to also ask another question to the whole group, especially those who have some experiences with going back to any part of the region and trying to find their way and kind of try to find application of the things that they picked up from abroad or their research, and kind of trying to find opportunities to apply what they have learned in terms of computational design. I mean, this is a general question. Do you think there are opportunities here in the region that kind of allow you to utilize what you have learned and to kind of apply it in ways that are also kind of responding to our culture and to our context at the same time? So I'm curious to hear, especially from the people here that are that have went back home or have tried to go back home and have tried to find ways to apply what they have learned abroad. What are your thoughts on that?
I think definitely it's something that I try to do. So I try to apply this in the traditional field of urban design and landscape architecture, and it was a very it's a much more to me, it was much more reserved in that sense, that people are still not very accustomed, but it has a lot of potential, and they're opening up to it slowly. Maybe the art world is a bit more lenient towards this change, and it can offer a lot more experimentation. And so that's why I was leaning to go into the arts in parallel with my urban design work.
No, that's really interesting. Who else kind of have some experience in trying to apply some of these research and kind of work in different places in the region?
Well, I think I think you know better. You know as much as I. I'm gonna speak within my experience. So I'm gonna speak within a corporate context. The reality there is that you need to push whatever is marketable, but at the same time, even when you're trying to push boundaries in terms of how things can be done, it's a long process, and there's very limited understanding to the value of what we present. The only thing you get right now is just make it parametric, like whatever it is, what we have, and it's always kind of a face value kind of modification. I think there's still a lot of potential to I think we're a long ways to go, honestly, at least in because when you talk corporate, you talk real life application. Unfortunately, this is a whole other discussion on itself. We can open up an entirely different platform for that. That's the reality in so many countries, for that matter. So, yeah.
Yeah, I think
Ahmed is asking.
Sorry, I think I'll have to agree with Muhammad that there are actually challenges that we are definitely willing to go and serve and put our expertise in that region which we come from. But there are a lot of limitations, which is basically not really encouraging us. But I'm sure it's changing. The situation is changing, and it is getting better, and it is getting there slowly. So I definitely have a very high hope on that.
So what do you think sorry. Who was
go ahead. Yeah, I'll go next.
No, go ahead.
Yeah, thank you. These are really great comments, and I really like this question because I studied in the US. I get my bachelor from there, and then I went to the AA, and I was exposed to these technologies and computation tools and all this material understanding that is embedded actually in all of the prototypes, the amazing prototypes that we make, the computational tool that we experiment with. And I saw the potential of these tools, right? And then when I went back to my country, came from Kuwait, everyone was surprised. It's like, are you serious? Are you gonna use this here in Kuwait? We have a traditional way of making things. Even the school reject this idea of embedding this culture in them. But I tried to force that. So I started this initiative, the AA architecture, visiting a school in Kuwait, where we focus on design and build. And they loved it. Oh, yeah, this is really something great for us. It creates all these wonderful spaces, and it utilized the material in a different way, in a novel technique, using just the tool that are available in Kuwait. So bridging the gap, this gap between material, design, understanding, and the culture was very powerful and needs initiative from people like us to push things forward. I think this is the takeaway lesson that I got back from my home country. Yeah. And going all the way forward once I finish my degree. Yeah.
And actually all the visiting schools are truly making a difference, and like making people more exposed to these tools and to the schools and all the like digital architecture we're talking about.
Yeah, like I guess, sorry, go ahead. No, go ahead.
Okay, so I also wanted to say that at least speaking from my experience, there is something that needs to be addressed in the way that we study and practice architecture, at least in Iran. And I think everything is super like categorized. There is a lack of sense of playfulness and experimentation. And that is something that I was extremely excited when I started like studying at the Bartlett, and the way that architecture was approached as a multidisciplinary, super collaborative field. And I think that is what I've been trying to do when I visit back home and running a few workshops. That is what I want to do, just kind of make everyone excited and yeah, just fall in love with the architecture again. Because if you're in the architecture field for a couple of years, you always start to have like a certain feeling towards it. And I think just bringing that playfulness and experimental nature back, and just feeling like it's an open field for collaborating with dancers, with fashion designers, with filmmakers, with composers, and anyone who comes from a creative or even scientific background. There is something that you can have a conversation around as an architect. And yeah, that is absolutely wonderful.
That's amazing. Yeah, I think like kind of the point that I wanted to mention is what do you think can be done to kind of change the misconceptions or the kind of the ideas and thoughts in the region regarding, you know, more experimental kind of work or architecture or design? Like, what do you think that can be done, or what is our role then to kind of change the hearts of these kind of societies to be more open and accepting of new experimental kind of work? I'm curious to hear from you guys. Ahmed, you have some experience. You have some
I was just
personal
asking in the chat, yeah.
Yes, go ahead.
I believe maybe the first point, the start, is like by education. As if you would like to introduce something into a community, you need to reach the gap at first. So maybe reaching the gap would be easier from the student side. So when you feed the students with new ideas and techniques and so on, they will pass this to their like local communities and so on. And within time, you can spread the word for everyone. And so when it comes to businesses, when you speak with someone who introduced to something by his son or his son friend or something like this would be easier than just for first time ever to see this thing and these ideas and so on. And I totally agree with Suleiman, as he mentioned, everyone should like do his best to spread the word and introduce these ideas to these people, as you should expect they will not agree with you if they never heard about this before. Yeah, thank you.
No, thank you, Ahmed. That's a very, very good point. And I totally agree. I think the younger generations and students in the region, they have such a hunger for this kind of knowledge and for this kind of work. And I think there is a huge interest in this kind of field as well. And I think we are slowly changing the attitude towards this kind of experimental work. And as much as there are a lot of challenges, especially in the hands of kind of like decision makers or leaders, I think there's also a lot of opportunities once they, as Sulaiman mentioned, like once they see some kind of output or result from a certain workshop, they get excited about it. They're more aware of the capabilities that can come out of this kind of experimentation. So they are more open to kind of continue this kind of work. I think Bavleen also had a question for Sulaiman. Bavleen, would you like to mention it, or should I read it?
Yes, please go ahead. No? Yeah.
Was it in the chat?
Yeah, it was in the chat. Bavleen, go ahead.
Yeah, hi. So I actually have a more of a technical question. Very interesting conversations, though maybe I'll just have a more focused question here. So Suleiman, I wanted to ask a little bit on, are you doing any kind of prediction of clade deformation in your digital simulation as well?
Yes, in my current doctorate studies, yes, I am developing this simulation tool that could predict those complex lattice structure. And the simulation tool was based on a data-driven approach. Like I have printed 200 samples already, and just collected data from there from these samples to create my training set, and then just using a standard artificial neural network to guide the simulation and the prediction. Yeah.
Another question that I had again for you is that are there any considerations regarding the print time as well when you are designing your toolpaths with your voxel method that you're proposing?
Yeah. The print time is tremendously reduced, for example, and I showed that with the technique that we developed, and the print time also can be optimized based on any geometry that you input in the toolpath generator. So you can look for highly reduced fabrication time, but there are certain implications when it comes to that. You will end up with more porosity, maybe less structural performance. So there are some optimization that need to be taken into consideration. Yeah.
Correct. Okay, thank you.
Yeah.
Thank you so much, Bavleen, for your question, and thank you, Sulaiman. Another kind of thought that I had, and maybe I can direct this to Sally. how do you find your background in this kind of experimental work and research? Like, how much of it do you feel like you're applying it, for example, in your daily like job working in such a big corporation?
Yeah, actually, that's a very good question. I had a slide at the end of my presentation that's basically connecting dots between theory and practice, between academia and work. I have to say that having the digital knowledge really helps you a lot in the design process, whether it's form making or form finding, or whether it's experimenting with materials or with geometries. So having this background really helps you and helps the way you think, the way you design, and the way you approach any brief or any new project. At the same time, I believe that the architect is the main leader, is the main designer, and these tools basically are utilized to serve you, to achieve your thoughts. I truly and personally believe that it's part of the process. It's not the main aim. It's part of the process to achieve what you want in a very sustainable way, in a very functional way, and a very efficient way, and of course, beautifully looking. So yes, it's important to have it, to know it, to use it, and at the end, let it help you to achieve what design you want. Also, having these tools will help you to design projects in different contexts. So of course, as architects, we don't know all the contexts we're working on or the different climates. So for example, having the climate analysis tools will help us understand which climate are we working on. And that's gonna, of course, influence and be a parameter of our design. So I truly believe every architect should have a knowledge, a basis, understanding of these tools to utilize it to help you in your design process. Yeah.
Very, very well said. Thank you. Thank you for that.
Yeah.
I think I would also direct the same question to Basant, like from your practical experience, how much do you feel like you were able to borrow from your research or apply throughout your entire like experience and practice?
I think that like overall the experiences that I had at the DRL and generally in academia like transformed who I am as a person and my kind of like honed my intuition in ways that, you know, have really shaped my approach to everything that I deal with in the corporate world or now in like a smaller office environment. And like Sally said, it's like a toolbox of tools that you can just reach into whenever you can and whenever you're allowed to, I guess. It's a constant like back and forth. I don't want to say fight, but it's kind of a fight of trying to.
It's a balance.
A balance, yeah, that's a better word. Of trying to you know, introduce these things to the practical world and trying to make something more than just applying a pattern to a wall when someone asks you to make it parametric, as Ahmed mentioned earlier.
Very, very well said. Thank you. Thank you, Basant, for that. I think this is it for me with my questions. If anyone else has any questions or if there is a question from the audience that I missed. Neil always wants us to speak in any other language. All right, so thank you everyone for taking the time to be with us today, and it's truly been inspirational, and I'm very excited to continue following your journeys, whether in practice or in academia. It's truly eye-opening for all of us, and we really learned a lot from every single one of you today. So thank you so much for your time. Neil and Ahmed, did you want to mention something about the coming event?
Yes, let me say something first, because I want Ahmed to finish off speaking some Arabic, because I think it's really important. I mean, Ava is I think is a Farsi speaker, but it's fantastic to always hear these languages and to remind ourselves, where you guys come from, where the talent is in many ways. So it's but just to say, I mean, tomorrow we have I think a very special session for the doctoral consortium. This is the idea is really is to create this platform for everyone all over the world where we can come together and we've had some really fantastic sessions over the weeks, including, of course, contributions from the Middle East or West Asia, I'd like to say. Beraz Ferrari was on for our session on Foucault. Tomorrow we have Jacques Derrida and Helen Sixou. And I just want to say that Jacques Derrida and Helen Sixou, they come from Algeria. I mean, they're Jewish and they moved to Paris, but they come from actually an Arabic-speaking country, and let's not forget that. And so anyway, we have I'm really delighted to have tomorrow Bernard Schumi, who's been recorded, but it's a fantastic thing that he said. Peter Eisenman and Doina Petrescu. Doina Petrescu studied under both of them, and she is from Romania. I think it's been fantastic to have this platform to create this space for debate. And the other thing I wanted to say is that we are deliberately moving forward, trying to. In an architectural way. I want to stress this is an architectural project. It's kind of imagining the possibility of working with systems to try and use this platform, not just to be a kind of. I mean, I feel as someone who's brought up speaking English that it's almost imperial to speak English the whole time. So we want to open this up in many ways towards different languages. This was part of Inclusive Futures. We had 10 different languages for Inclusive Futures over the summer. And we want to kind of create different platforms for different languages at different times. For example, I know that a Friday is the beginning of the weekend in the Muslim world. So we're going to have Arabic and Farsi sessions once a month to begin with. We'll just try them out on a Friday. And then we want to move on to Spanish and Portuguese and Russian and who knows what else. There are already Chinese sessions going on. So to make the platform really a multicultural platform and not just using, I mean, of course, we use Arabic numerals the whole time, okay? Arabic numerals and English language, but we want to open it up in different sort of ways. And the other innovation we're doing, and we're gradually doing this, is to take some of the talks that actually they're all kind of TED Talk-like in the end. They're short TED Talk ones, and to extract some of the key ones and to have them with subtitles in these languages, subtitles and transcripts, very much like the TED Talk. So that's an ongoing project that we're doing, and we hope to see that soon. But it's really part of embracing this amazing platform, which I just want to go back to Ahmed's got a comment. Ahmed, you must go. I don't know if you've been to London yet, but when you say gap, that if you go to the underground the whole time, they say mind the gap the whole time. But we want to actually bridge the gap, right? In many ways, bridge the gap and connect this thing. And I just want to say that also, just one thing to add to what was being said before, let's not forget, where all this came from. To my mind, I thought was so beautiful about, I think it was Sadie's presentation where she was showing these amazing structures that have been created between the Euphrates and the Tigris, really beautiful things that actually, while we have a computational world, it's really, to my mind, AI is about intelligence, and there is an intelligence also in traditional things. I know that from Berroco Neves that he was always looking at some of the vaulting systems that came from traditional structures when he was thinking about his control crafting. So to my mind, it's about bridging the gap between old and new, between East and West and all over in different languages. So hopefully this platform will be the beginning of something. You never know when you set these things off what they will grow into, but something amazing is going to happen. I just wanted to thank Aya for what was a really one of the best sessions. And I loved the questions. I loved the answers. The discussion was really incredible. But to say, well, this is fantastic. Let's see where this leads to, and I look forward to hearing Arabic not just only today, but also in the future on Digital Futures. And also Farsi, because it's so important for all of us to understand that we're in this all together. It's a worldwide global community, and we need to share resources. And so thank you so much today for your contributions. And over to you, Ahmed. Thank you. Thank you, Aya. Wonderful session. And thank you also the team behind this that put this together. There are many others involved we don't see, but thank you so much, everyone.
Thanks a lot.
Yeah, thank you, Professor Neil. Yeah, أنا سعيد جدا والله إن أنا هتكلم بالعربي بين قوسين بالمصري طبعا. إن شاء الله الفترة الجاية يكون عندنا لقاءات كتيرة بالعربي. يعني إحنا بنجتهد إن إحنا نجيب القصص الملهمة زي الأبطال اللي إحنا شفناهم النهاردة. إن شاء الله نجيب أبطال تانيين. أنا حاولت أريتش ليهم خلال المؤتمر عشان يعملوا ورش، وإن شاء الله نريتش ليهم تاني وتالت وألف. أنا متحمس جدا الحقيقة، وبروفيسور نيل متحمس جدا جدا جدا، متفهم ان في ناس بتعاني عشان تقدر تفهم اللغة، ولذلك عايز يعمل فيديوهات بلانجوج مختلفة. يلا نشوفكم على خير، تحياتي.
Thank you all. Thank you, Neil, and thank you, Ahmed, so much. Thank you, everyone, again for your time. It was a pleasure, and we hope to see you again with us soon.
Thank you very much. Thanks a lot.
Hey,
Bye-bye.
before no, just sorry. Before we go, I just wanted to do this just real quick for next week. Do you see the screen? Ahmed, do you want to make the announcement for this?
Yes, we
No,
see
you go. Yeah.
All right. So I just wanted to bring everyone's attention that next week we have a wonderful technical tutorial, developing custom components in Grasshopper with Python. For more information, you can actually join us online, or you can look at the link below on Zoom and join us so that you can actually ask in real time questions to the instructor. And one last thing, this was last week's technical tutorial. So our colleague Bavleen is heading up this initiative for Digital Futures. So please, if you have not, review that and all of our other technical tutorials and past events. And for more information, if you want to join Zoom, the team, or behind the scenes, please contact us at info@digitalfutures.world. Thank you.
Thank you so much, Gustavo, for this. And again, thank you, everyone. I hope you have a great day, night, and we hope to see you all again soon. Bye-bye.
Bye.